You are 64 years old and you have been doing everything the fitness magazines told you to do. You drink your protein shake every morning. You eat chicken breast at lunch. You add a scoop of whey after every workout. Your protein intake on paper looks better than most 25-year-olds. And yet, when you look in the mirror, the muscle you are working so hard to build is not showing up the way it used to. Your arms look smaller than they did 5 years ago. Your grip feels weaker opening a jar. Climbing a flight of stairs takes a little more effort than it should, and you start to wonder if something is broken. If your body has simply stopped responding to protein the way it used to, and the uncomfortable truth is you are right, something has changed. But it is not what you think. Protein is not the missing piece. Protein was never the whole story. Today I am going to walk you through the actual biology of what your muscles need after 60. The real signal that tells your body to build muscle, and why so many people over 60 are eating enough protein and still losing muscle. Before we go further, if this kind of deep biology content is useful to you, take a second and subscribe to Winds of Thought. It genuinely helps this channel keep making videos like this one, and it costs you nothing. Now, let's get into the science. For decades, the fitness industry has told a very simple story. Muscle is made of protein, so if you want more muscle, you eat more protein. And on the surface, that logic makes sense. But the human body is not that simple, and nowhere is that more obvious than in people over the age of 60. Researchers have a name for what happens to muscle as we age. They call it anabolic resistance. And once you understand what that term actually means, the whole protein story starts to fall apart. In the way people usually explain it, anabolic resistance means that as you get older, your muscle tissue becomes less responsive to the normal signals that tell it to grow. The same plate of chicken and rice that would trigger a strong muscle-building response in a 30-year-old produces a much smaller response in a 70-year-old. This is not a theory. It has been measured directly in laboratories. Researcher Kevin Cuthbertson and his colleagues at the University of Nottingham compared muscle protein synthesis rates between younger and older adults given identical amounts of amino acids. The older group showed a significantly blunted response. The muscle tissue simply did not respond to the same dose of protein the way younger tissue did. This single finding reshaped how scientists think about aging muscle. It is not that older adults do not need protein. They absolutely do. But protein alone is knocking on a door that has become harder to open. So what is the door, and what actually opens it? This is where most protein-focused advice stops short. Because the missing piece is not a nutrient at all. It is a mechanical signal. Your muscle fibers are covered in structures called integrins. These are tiny protein complexes sitting on the surface of muscle cells that act like sensors. When a muscle fiber is placed under tension, when it is stretched and loaded the way it is during resistance exercise, those integrins physically deform. And that physical deformation triggers a cascade inside the cell, involving a protein called focal adhesion kinase, which in turn activates a pathway called mTOR, mechanistic target of rapamycin, the master switch that turns on muscle protein synthesis. This process is called mechanotransduction, the conversion of a mechanical force into a biochemical signal. And here is the part that changes everything. mTOR responds far more powerfully to mechanical tension than it does to amino acids alone. Protein without mechanical loading is like delivering bricks to a construction site with no crew there to use them. The bricks pile up. Some of them get used for basic maintenance, but nothing new gets built. Mechanical tension is the crew. It is the signal that tells the body this tissue is being used. It needs to adapt. It needs to get stronger. And that signal becomes even more critical after 60 because of a second phenomenon researchers have identified called anabolic resistance to mechanical stimulus as well. Meaning older muscles need a higher dose of mechanical tension to trigger the same growth response that a smaller dose would trigger in younger muscle. There is also a hormonal layer to this story that most protein-focused content completely ignores, and I think it deserves real attention. Testosterone and growth hormone both decline gradually after midlife, and both hormones play a supporting role in muscle maintenance. But here is the detail that surprises most people. Hormone replacement studies have consistently shown that restoring testosterone or growth hormone levels in older adults without adding resistance training produces only modest changes in muscle strength and function. Researchers running these trials again and again see the same pattern. Hormones can support the environment for muscle growth, but they do not replace the mechanical trigger. This is sometimes called permissive versus instructive signaling. Testosterone is permissive. It creates favorable conditions, but mechanical tension is instructive. It is the direct order that tells specific fibers to adapt. You can have every hormone in your body at a perfectly youthful level, and without mechanical loading, your muscle tissue still will not receive the instruction to grow. This is precisely why some older adults on hormone therapy are surprised when their strength does not improve the way they expected. The hormonal support was there. The instruction never arrived. This connects directly to something called the satellite cell system, and I think this is one of the most fascinating parts of muscle biology that almost nobody talks outside of exercise science departments. Satellite cells are a special population of stem cells that sit on the outside of your muscle fibers, dormant, waiting. When a muscle fiber experiences enough mechanical stress, those satellite cells activate, they multiply, and some of them fuse directly into the existing muscle fiber, donating their nucleus to it. This matters because each nucleus inside a muscle fiber can only support a limited amount of surrounding tissue. A concept called the myonuclear domain. As we age, we naturally lose muscle fibers and satellite cell activity slows down. Researcher Charlotte Peterson and her team at the University of Kentucky have shown that older muscle has a reduced satellite response compared to younger muscle following the exact same exercise stimulus, which means older adults need consistent mechanical loading just to maintain the satellite cell pool they still have. Without that stimulus, the myonuclei you have slowly become insufficient to support the muscle tissue surrounding them, and fiber size shrinks. Not because you stopped eating protein, but because nothing told those fibers they were needed. If you are finding this useful, drop a comment and let me know where you are watching from. It helps this video reach more people who need to hear this, and it costs nothing but a few seconds. Now, let's talk about fiber types because this is where the story gets even more specific to people over 60. Your muscles contain two broad categories of fiber. Type 1 fibers, which are slow twitch, built for endurance, and type 2 fibers, which are fast twitch, built for power and strength. Research consistently shows that aging disproportionately affects type 2 fibers. A landmark study by researcher Lars Larson and colleagues found that type 2 fiber area shrinks significantly more than type 1 fiber area across the aging process. This matters enormously because type 2 fibers are exactly the fibers responsible for the strength you need to stand up from a chair quickly, catch yourself if you trip, or carry a heavy bag of groceries up a flight of stairs. And the only reliable way to preserve type 2 fiber size is to load them specifically through resistance training that challenges them near their capacity. Slow walking, gentle stretching, and light daily activity are valuable for many things, but they primarily recruit type 1 fibers. They do not deliver the mechanical tension threshold that type 2 fibers need to avoid shrinking. This is why you can see people who are active every day, who walk regularly, who eat a clean, high-protein diet, and who are still losing visible muscle mass and strength year after year. They are missing the specific mechanical input that only resistance training reliably provides. There is one more mechanism worth understanding here, related to motor units. A motor unit is a single nerve cell along with every muscle fiber it controls. And as we age, we naturally lose motor units, particularly the larger, faster ones responsible for generating powerful, quick movements. When a motor unit is lost, the muscle fibers it used to control do not simply disappear. In many cases, nearby motor units send out new nerve branches and adopt those orphan fibers. This process is called motor unit remodeling, and it can partially compensate for the loss, but the resulting motor units tend to be slower and less powerful than what they replaced. Researcher Jeffrey Power and colleagues have documented this remodeling process extensively in older adults. And the encouraging finding within that research is that resistance training appears to support healthier motor unit function and can slow the rate of motor unit loss, particularly when the training includes some element of speed or power-based movement, not just slow controlled lifting. This is why many exercise scientists now recommend that older adults include at least some faster, more explosive movements within a safe range, like standing up from a chair as quickly as good form allows. Because the nervous system, just like the muscle fibers themselves, needs a reason to preserve its fastest, most powerful pathways. And that reason has to come from use, not from diet. Now, let's bring protein back into the picture properly, because I do not want you to think protein is unimportant. It absolutely matters, but the way it matters changes after 60. Researcher Douglas Patton Jones at the University of Texas Medical Branch has spent much of his career studying exactly this question, and his research shows that older adults need a higher single dose of protein to maximally stimulate muscle protein synthesis compared to younger adults. Where a younger person might trigger a strong response with around 20 grams of high-quality protein in one sitting, older adults often need closer to 35 or even 40 grams in a single meal to achieve a comparable spike in synthesis. This is sometimes called the muscle full effect, and it also comes with a related insight about a specific amino acid called leucine. Leucine acts almost like a key that fits directly into the ignition of the mTOR pathway. An older muscle appears to need a higher concentration of leucine to fully turn that ignition, only 2.5 to 3 grams of leucine per meal, which is why protein sources rich in leucine, like eggs, dairy, and quality meat, tend to outperform lower leucine plant sources on a gram-for-gram basis for this specific purpose. But here is the critical detail that so many people miss. Leucine can turn the key, but if the ignition itself has not been primed by mechanical tension, the engine still will not run at full power. Protein sets the stage. Mechanical loading raises the curtain. You need both. And most people over 60 who are struggling to build or even maintain muscle have quietly assumed that fixing their protein intake was the whole solution, when in reality it was only ever half of it. There is also a recovery and sleep component that deserves mention because it directly affects how well the mechanical signal we have been discussing actually gets translated into new tissue. Muscle protein synthesis rates remain elevated for roughly 24 to 48 hours following a resistance training session, and a significant portion of that repair and rebuilding work happens during deep sleep when growth hormone release naturally peaks. Older adults often experience lighter, more fragmented sleep due to natural changes in sleep architecture, which means the repair window that follows a training session may not be used as efficiently as it would be in a younger person with deeper, more consolidated sleep. This does not mean the effort is wasted, but it does mean that protecting sleep quality through consistent bedtimes, limiting late caffeine, and managing stress becomes part of the same system we have been describing. Mechanical tension creates the opportunity for growth. Protein supplies the raw material, and sleep provides much of the time and hormonal environment in which that material actually gets assembled into new tissue. Skipping any one of those three does not just slow progress slightly. It can stall it almost entirely, which is part of why some people who train hard and eat well still see disappointing results if their sleep has quietly deteriorated for years without them addressing it. This is exactly why so many well-meaning people over 60 end up frustrated. They follow the nutrition advice diligently, they track their protein, they buy the shakes, and they still watch their strength decline. And it is not a failure of discipline. It is a gap in the information they were given. The fitness and supplement industry has an obvious incentive to keep the story simple and centered on products you can buy and consume. A tub of protein powder is easy to sell. A consistent resistance training habit is not something you can put in a container, but the actual physiology does not care what is easier to market. Muscle tissue over 60 responds to a combined signal. Mechanical tension first, adequate protein and sufficient leucine second, and consistency across weeks and months third. Remove any one of those three, and the system underperforms. This is also why research on resistance training in older adults is so consistently encouraging. A well-known study led by researcher Maria Fiataroni at Tufts University tested resistance training in nursing home residents with an average age in their late 80s. And even in that population, strength increased by over 100% in a matter of weeks. Some participants who needed a walker to move regained the ability to walk without assistance. Muscle tissue at any age retains a remarkable capacity to respond to the right mechanical signal. It does not simply give up protein as the fuel, but mechanical tension is the engine. Both are essential. Neither works alone. So what does this actually look like in practice? And I want to be specific here rather than vague, because vague advice is part of the problem. Resistance training after 60 should involve major muscle groups. Work to a level of meaningful effort. Roughly 2 to 3 times per week is enough to maintain and even build muscle when done consistently. The load does not need to be extreme, but it does need to be enough that the last few repetitions of a set feel genuinely challenging. Bodyweight movements like sit-to-stand exercises, resistance bands, and machine-based training at a gym are all valid entry points, and the mechanical tension principle applies regardless of the tool you use. Alongside that, protein should be distributed across 3 to 4 meals per day, rather than concentrated at dinner, with each meal ideally containing that 30 to 40 gram range of high-quality leucine-rich protein: eggs, Greek yogurt, fish, poultry, and for those eating plant-based, combinations of legumes and soy-based proteins in larger portions to reach the same leucine threshold. And finally, this needs to happen consistently, not for one motivated month, but as an ongoing pattern. Because satellite cell activity and myonuclear support respond to sustained signals, not isolated bursts of effort, it also helps to track something beyond the scale, because weight alone hides what is actually happening underneath. Simple measures like how many times you can from a chair without using your hands in 30 seconds, how far you can walk at a steady pace, or how much you can comfortably carry up a flight of stairs, all give you a clearer picture of functional strength than a bathroom scale ever will. And tracking one of those measures every few weeks gives you real feedback on whether the mechanical signal you are providing is actually being received and acted on by your muscle tissue. It is also worth addressing a common fear directly because I hear it often. Many people over 60 avoid resistance training out of concern that lifting anything heavy will hurt their joints or put them at risk of injury, and the research actually points in the opposite direction. A systematic review of resistance training safety in older adults, published through work coordinated by researcher Maren Fragala and colleagues associated with the National Strength and Conditioning Association, found that properly supervised resistance training has a lower injury rate than many forms of recreational activity, including walking on uneven outdoor terrain. The key phrase there is properly supervised. Starting with lighter loads, learning correct movement patterns, and progressing gradually is what makes resistance training both safe and effective. The joints themselves generally benefit from appropriate loading because the muscles, tendons, and connective tissue surrounding a joint become stronger and more stable, which in many cases reduces pain rather than causing it. Arthritis sufferers in multiple clinical trials have shown measurable improvements in pain and function through structured resistance programs. The outdated idea that older adults should avoid resistance work to protect their joints has in many cases been quietly working against the very outcome people were trying to achieve. I know some of you watching this are thinking about a parent or a grandparent, someone in their 70s or 80s, who has started to look visibly frail. And if that is you, I want you to hear this clearly. It is genuinely not too late. Muscle tissue does not have an expiration date on its ability to respond to mechanical loading. The research from Federoni and many others since has shown responsiveness well into the 9th and 10th decade of life. The biggest barrier is rarely biology itself. It is the belief that decline past a certain age is simply inevitable and unchangeable. That belief keeps people on the couch, and the couch is the one environment where none of the mechanisms we just talked about, integrin activation, mTOR signaling, satellite cell recruitment, ever get triggered at all. Muscle tissue does not distinguish between someone who is 62 and someone who is 32 when it comes to the fundamental question of whether it is being asked to do work. It only knows whether tension was applied or not, and it responds to that answer with remarkable consistency across nearly every age group that has ever been studied, which is genuinely one of the more hopeful findings in all of exercise physiology. Decline is common, but it is not automatic. The difference is often just knowing what your muscles are actually listening for. Decline is common, but it is not automatic. And the difference between the two often comes down to whether someone ever received this specific piece of information at the right moment in their life. Before we wrap up, if you know someone over 60 who is doing everything right with their diet and still frustrated with their strength or muscle, send them this video. It might be the missing piece they have been looking for. And if you want more videos that dig into the actual mechanisms behind aging, strength, and the body, subscribing to Winds of Thought means you will not miss the next one. Let me leave you with the core idea one more time, because I think it is worth holding on to. Protein is not what builds muscle after 60. Protein is a necessary ingredient, but the actual trigger, the signal that tells your body this tissue matters and needs to be preserved and strengthened, is mechanical tension delivered through resistance training. Your muscles are listening for that signal every single day. And the question is not whether you are eating enough protein. Most people already are. The real question is whether you are giving your body a reason to use it. Tomorrow, instead of just reaching for another shake, consider picking up something heavier than usual. Your muscles at 60, 70, and beyond are still listening. They are still capable of answering. They are simply waiting for the right message. And every single day, you have a small, repeatable choice in front of you. Whether that message gets sent or not, that choice, more than any shake, any powder, or any label on a protein bar, is what will decide how strong you still feel 10 years from today. If this changed how you think about protein and muscle, hit that like button and subscribe to Winds of Thought for more science that rewires how you age.